So I'm going to be spending some time today talking about how event architectures go wrong and how to fix them. So over the last few years, I've been working with lots of people in this room as they've started to build event-driven architectures, and we see some pretty common themes. Some of them Dave will have touched upon in his talk earlier, and hopefully I'll dive into a little bit more detail. And I'll also try and provide some answers. So it's scary out there. There's lots of ways that we can get caught up by all this complexity. But I'll try and give you some specific things that you can do to address that. So I'll start off talking about what are we actually trying to do with event-driven architectures. We're here at EDA Day in London. We obviously care about it. We think it's an important thing, and it's something that's been important throughout my career for the last kind of 20 odd years in technology. Our kind of high-level goals for event-driven architecture is we want to build scalable organizations. We learned pretty early on that having 200 engineers working on the same thing, committing to the same code base, and releasing twice a year was a pretty rough ride when you're building technology. We want to be able to have small teams, 2 pizza teams, that can work on very, very closely aligned to a piece of customer value. And they have independence, and that's great because that gives us some agility. Instead of having those biannual releases of hundreds of engineers, we can have hundreds of teams releasing multiple times a day, and we can start to get business agility. Because we're releasing all the time, we get fast feedback loops, so we can ship to production, we can get some data, we can use that data to inform our next step in our journey. The reason we can do that is because we've got fewer external dependencies. So Dave talked a lot about coupling, and I'm going to talk about that a lot more. So a team can ship, and it doesn't have to care about all the consumers of the data that they're producing. They can just ship, and as long as they conform to the patterns and contracts they've agreed upon, no one really cares if they change language, change platform, change the way that they build their the implementation details of their solution. And everything breaks all the time, and these teams who are shipping multiple times a day are going to be releasing problems into production. So when things break, we want to break the smallest possible unit of work so that actually our customers can still go through broader journeys. And when that system comes back up, we've also got patterns to go and recover from error so that we can get that service back up to where it should be as quickly as possible. And the broad kind of high level from a helicopter view of how we're doing this is we want to have these stream-aligned domains where people have some sort of shared goal and shared cadence of how they're working, and they have got a really common place. So if I am in the finance team and I want to share some information that might be used by logistics or support, they can push that on an event bus. And if I'm in the finance team and I need something from the retail team or the logistics team, I know where to look. It's going to be on the event bus, and I can look in my event catalog and find it. So that's all great. They talked briefly about ubiquitous language. So wrapped up with this whole domain model and this idea of scale and organizational scalability is, if we want to have 200 small teams, we don't want to have 200 meetings a week in order to ship. We need to know that the people within that team all understand what they're talking about, and they have a ubiquitous language. So when they're talking about orders or invoices or products, that within that team, it's pretty clear, and they don't have to keep referring to documentation or trying to find out what the single source of truth is. And that helps us get this kind of those upfront goals that I talked about. So for the next 40 minutes or so, I'm now going to talk about the great goals and why doesn't it work? What can possibly go wrong? So just introduce myself. So my name's Matt. I'm a blue belt in Brazilian Jiu-Jitsu, so I spend most of my mornings waking up early and trying to strangle my friends on the mat. And I've got 8 years left to get my black belt before I'm 50. So that's one of my big life goals. I do a whole pile of serverless stuff at AWS. I'm a specialist, and so I lead our business for UK and Ireland. Within that serverless specialism, I specialize a bit further. So my real kind of topics of interest are Java modernization, what platform engineering and platform teams look like in a serverless world, and of course, we're here today talking about event-driven architectures. So we start off with it, when we're building software, it's a relatively common process. whatever kind of agile framework or structure you're using, fundamentally there's some sort of requirements gathering. We're speaking to the business about what we should do. We're then designing some software that meets that requirement, and we're building it, and it's 2024, so hopefully these are getting shorter and shorter, and we're optimizing for flow, and we're trying to get a little bit of requirements, doing some light touch design, and getting that work into production, delivering value as quickly as possible. So far, so good. So this brings us to our first anti-pattern, YOLO. Do people know what YOLO stands for? Lots of nods, you only live once. So David coined this anti-pattern, and I'm trying to get it into broad usage across the community. So I really like the idea of YOLO events. I've got a few new terms that I've coined myself today, so let's see if we can also make them common parlance in the EDA community. So YOLO events, we start off with our basic system. Some of this you'll recognize from Dave. So we create an order, we go in and we create this very, very sparse order. So what we care about at EventBridge is our detail here, and we've been sparse, and we've tried to keep things simple, in line with the principles that Dave talked about. And so we've got an order ID, a user ID, and event ID. Because they're stored that way in the database, we've used camel case, so we've got lowercase u, uppercase I, because why not? And we ship that to production with our custom data, and that's great, and it's delivering value. Next team comes along, and they're going to do some fulfillment events. We get our fulfillment event, and we've now learned a little bit about idempotency, because we've figured out that EventBridge isn't strictly ordered, and it's at least once, and we've started seeing duplicate events. And we now need a way to deal with those duplicate events. So we want to stick it somewhere, and we've read a blog post by Dave, and it's told us, actually we should be splitting out our metadata and splitting out our data. So we've done that. We've added this idempotency key. We also split out our data, so we've now got our data in a separate object. And so that's great as well. That makes it easier to scale. We also noticed that the EventBridge types are hyphenated, but before we'd shared some implementation details, so we'd used camel case user ID. We decided to move to hyphenated properties. We've done this across all of our events. We're going to set this as a standard, and we're going to document it in Backstage for everyone to use. So excellent. Now, our order-created events are being used by all of our teams. They're still delivering value. So all of our consumers are now going to go and build a little mix-in their consumer code that's now going to go and check it to convert our camel case user IDs to hyphenated user IDs and try and standardize that. So we're going to use some sort of anti-corruption layer already on our second event to fix a whole bunch of the challenges that we've seen. Next team comes along, order cancel. They're feeling better about the world because they can go in and look at our standards. So they go into Backstage, have a little look, and they go, OK, I've got to split out the metadata into a separate object. I've got to add an idempotency key. I've got a separate object for data, and I've got to hyphenate all keys. Tick, 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 tick. This is great. However, TW, Dave never told me what TW stands for, and nobody knows, but it's in there, and we don't know if somebody's going to depend on it. We've got a cancellation reason, is it descriptive? We've also got a user object, but I think that one of the most nefarious things that we see with coupling is actually this semantic coupling. So this user here has decided that first name is hyphenated because it's 2 words, but surname is not hyphenated, and a developer's decided this, and is this going to be the pattern that we adopt across our entire org, or is it just kind of accidentally out there? YOLO, it's fine, someone else will figure it out. I'll probably be working somewhere else when I get there. So very, very quickly, we can get there. We've got 3 events across hundreds and hundreds and hundreds of events and hundreds of systems. It can very, very easily get complicated. So some of the strategies that I think we can use to address that, we should define our standard somewhere. We should also be capturing these architecture decision records which say why we're doing things. So not just we're doing it like this, but this is the thought process, the discussions that got us there. We need to have a process to ratify new events. So a team wants to create a new event that's going to be used across the organization. We need to agree that that's going to be the standard that everyone uses. The way that I like to see that done is through an RFC process. I think there's a real challenge around having things like architecture review boards, which meet once a month, and I have to submit my events into the review board, and that review board has to approve things. That can be a real anchor on our agility and actually slow us down. An RFC process means that I can post an event schema. People have a window. They've got a month to give me feedback. If no one gives me any feedback at all, YOLO, let's go to production. They had their moment. But also, you can capture all of that feedback over the month, and the discussion that will probably happen around those events, at least if they're important ones, and I can capture that into your architecture decision record. You should probably start with smaller, sparse events, not really, really large, rich events. You need to plan how you're going to do versioning. So, what are you going to do, and how are you going to understand who is consuming those events? How do you know that everyone's moved into the new schema before you make that breaking change? And also, somewhere in this process where everyone's very, very streamlined and looking at delivering back value as quickly as possible to customers, you have to make sure that you've got enough time to invest in maintenance, in platform, in strategy that's going to be shared across all these teams. Next anti-pattern, I've got the Anubis here, the god of death from Egypt, and I thought it was an appropriate icon for my next anti-pattern, God events. God classes have been a thing in software engineering pretty much forever. One of the really, really common patterns, and there's a few people in the room that I've seen implement this, is having some kind of event on the object that everyone cares about most in the system. Here it's an order, but I've seen insurance policies, I've seen vehicle details. There's always one. And when things change on that object, people want to tell everybody that it's changed because it's important and everyone cares about it. So they're all adding additive changes into this event. So it's got way too much information. It knows way too much about the implementation details, so there's all sorts of leaky stuff that gets in there about how one system understands an object versus another system. It's absolutely not a ubiquitous language. It's really difficult to change because if you change it and it breaks, your entire business stops working because everyone cares about that event. And so because it's so difficult to change, instead of changing the stuff that's broken, we just add new stuff in at the bottom. And it just gets bigger and bigger and bigger over time. And because it's getting bigger over time and everyone depends on it, it gets more expensive over time. Because every single time you generate that event, you might have to call 5 different APIs. You might be calling different projected views across your system to go and ratify all these changes in sync across the whole system. So here's an event. This is our event here. We've got product data in our event. We've got fulfillment data, which looks a lot like product data, but actually it's a different implementation and a different ubiquitous language, but we chucked it in there as well. And the support team also is making stuff that's important for all these other teams, so it all gets added into that same event. And that's kind of a very, very lightweight version. I've seen these in hundreds, thousands of lines of JSON that's generated all the time across the system. So how are we going to avoid it? And part of it is domain-driven design, so do some event storming, start to build some bounded contexts, create your events from a bounded context only containing the information that is relevant to that team, and it's okay to have multiple events about orders created by different teams that have got different bounded contexts and different ubiquitous language. And I probably should have closed that down. But you might have multiple systems inside a bounded context that have got that ubiquitous language and are sharing some events, so a little bit nuanced. As well as breaking things down by event domain, I also think that we should be breaking things down by event types. So we've got the domain events. It's usually a noun with some verb created in the past, so order created, and those are really, really common. We want to split those out from things like our event carried state transfer events, so events where we are looking to someone's updated their address or changed the price of a product. Best not to mix those. One of the conventions I've seen is using fact, so we can have an order created fact, which is a change to an order. We can have notification events, so events in the system that are used to notify other systems. We can have a convention around those, order created notify. You also might have local events or private events that are only used within a particular domain. Dave talked a little bit about the process if you're making an event that could be used externally should be different to the process if it's used across the organization versus the process that you're using to ratify events with a team. So here I can namespace an event with order at, saying I'm only using this event within the order domain. If you don't live inside the order domain, depend on this event at your own risk, because we might change it without talking to you about it. And so it gives you some sort of model that actually all of those thousands and thousands of lines might break up into smaller events and have got a more clear, less coupled process. So the other side of GOT events is sparse events. So being too sparse with our events. So if we generate an event, my very, very first event was an order's been created and it just contains a user ID and an order ID. Everybody who depends on that event probably wants to know more information about that event. So as soon as I publish that event, they all call home, hit my API, to find out more detail about that order. And over time, more and more consumers start depending on that event, and I start getting essentially a reverse denial of service attack. So every time I publish it, I've suddenly got hundreds of clients all hitting my API and calling for that information. So really, it's a balance. We don't want to have too much information in our event, but we also want to have some observability on what content do people need to do to enrich that event? And if everybody needs the price and the title of the products in that order, maybe we should start including that in our event schema as well. Okay, anti-pattern 3, pinball events. This is really, really common. We've come to EDA Day, we're learning about event-driven architectures, and we love events, and so we're going to use events for absolutely everything. So inside our retail ordering domain, an order comes in, we fire off an event, we've got an orchestration function. That function needs to check stock, so it knows that the inventory manager is going to raise an event after that order up event, so it's listening for that event. Great, it's in stock, it hears that event. It needs to create an invoice that raises a new event for the invoice manager to go and create that event. That emits a new event with the invoice. And that finally creates this order created event. So we've got 7 events here just to get to that order created event, all happening within that domain. That order created event then goes and creates another half a dozen events in some other system, and it goes around and around and bounces around, and it's really, really, really difficult to reason about. We've got all sorts of challenges. So whilst events are great, it is just part of our toolkit. So the real power of events is it allows us to decouple between domains. I can ship from the ordering team, I can ship stuff and I don't have to talk to finance about it. But if we are in a team and we have a tightly coupled flow that has to work in a particular order, we shouldn't be afraid of orchestrating that, building that in a larger application, using something like step functions to orchestrate it or some other stateful system. And so we've got lots and lots of things in our architectural armory. We should be using the right tool for the right job. However, we shouldn't be afraid of essential complexity. The things we are building are difficult. That's why we have to use all these tools. And you often see that complexity in a really, really different way in EDA. So we might have a monolithic application that's got some modular code that is doing a whole load of work. It's a whole ordering retail system sitting in one project. And all that complexity is somewhere in that code base. And it's difficult to make changes to it, and it's tightly coupled, and we've got very, very little visibility on how complex it is. So it's really, really easy to represent it as a 3-tier application with a front end, some business logic, and a database. And our architects go, great, that's simple. We don't need to review anything else. And then suddenly we get to this event-driven architecture serverless world, and we've got boxes and lines everywhere. What we're really doing is exposing that complexity that's important to our system. It's making it easier to understand it in some ways, but it's essentially a different implementation of that same modularity. So if it is required for your system, don't be afraid of it. Just be mindful about where you are building decoupling and because there is a cost to decoupling. It's also super important to invest in observability when you're doing event-driven architectures. So we've got this stuff that is bouncing around, and it is always going to bounce around. I thought David's diagram was great with all of its boxes. We want to understand both the boxes and the lines. So we want to have some sort of distributed tracing. So when something goes wrong, we can go, okay, it's that Lambda function over there that is throwing an error, rather than just going to a monolithic solution where we are able to go and look at the logs on the box that's failed and find the issue. Okay, so my next anti-pattern, leaking the domain. So one of the patterns we see with event-driven architectures, Ben Ellaby's got a really, really good talk about minimum viable modernization later on, is going and taking some big old monolithic system running on the mainframe, and we want to go and eventify some of the data out of that system, and we want to use some sort of event bus, maybe we're streaming it to Kafka or to EventBridge, and then it's now living in an event in our modern world, and we can go and process it with all of our great Lambda serverless infrastructure or whatever kind of modern microservices implementation we want to do. So the most obvious thing to do is do some sort of change data capture, and we go and take whatever's the schema in that product catalog, and we go and turn it into JSON, and we publish that up to our event bus. So this is a real JSON schema from one of the big e-commerce vendor on-premise platforms that I pulled up, and it's really, really blurry because when I do the whole copy of the file, it's too big for PowerPoint, and I had to stop about a third of the way through because it crashes PowerPoint if I do a screenshot of the whole code in here. So it looks an awful lot like a God event. This is all kinds of implementation details, so it's got things about data structures, it's got things about rate limiting, it's all got sorts of stuff that we want to protect ourselves from in our new world. So we have got some patterns for it. So there's the conformist pattern. It's kind of the default. So we see people just accepting this event. And so time and time again, we see that whatever the ERP system is or whatever the warehouse management system just chucks out data, and it becomes the producer's problem. And it is what it is. Take it as it is. There are a couple of problems. So Dave briefly talked about them, but I'll try and dive into a little bit more detail. So we can have an anti-corruption layer. An anti-corruption layer is great. We can take that crazy product JSON, we can model what we care about as a product within our domain, and we can do some sort of conversion on that in our domain. We put it over at the consumer side, and a really, really common reason for that is because the consumer's got the budget. So they've actually got the use case that means that they've got the effort and the resources to invest in it. Therefore, we're going to own it there. Obviously, the trade-off with that is other consumers might have to do similar work again. So that might be a problem. We can also shift that the other way, so we can have an open host service where actually we're converting it as it comes out of the system. We're converting it into some standard that we've defined across the wider business. So we've now had to decide what our definition of a product is going to be, not just within that one domain who's building the anti-corruption layer, but actually in a wider organization. Get some more agreement about it, but we've got better reuse of that open host service. So there are lots and lots of trade-offs, and there are other kind of patterns that you might use to do that, as Dave mentioned. There's about a dozen or so of them, but definitely something to think about. So the next anti-pattern I see went from leaky events to what I call inside-out events. So we've gone into our organization. We've got a whole bunch of different teams. They've got different maturity. Some of these are off-the-shelf products. Some of these are legacy products. Some of these things are stuff that people have just bought and they're brand new and they're investing in. But the business has decided that we want to reduce customer churn because we think that's going to generate us a whole load of more money. And so we've written a great big check for the loyalty team, and the loyalty team has got budget to go and modernize and build a new event-driven architecture. So they go, great, off we go. We're going to start modernizing. We're going to build our serverless stack, and so we're going to build EventBridge. And they end up inside their domain with this Lambda pinball, and so we've got everything bouncing around with events inside their domain where, frankly, they could orchestrate. But they don't have the investment of the ERP team and the warehouse management team in order to go and both do the cross-organizational discovery and definition, or to go and build the open host services. So they end up accepting this conformist pattern from those events. They end up with this really tight coupling with the legacy systems and loose coupling internally where they can make changes. And so while there's some benefits to this process, it really fails to unlock really what we're trying to do with event-driven architectures. So while we've got this horizontal investment in loyalty team, we also need to go and convince our business that we actually want to build a platform capability, and we want to go invest in shared tooling. We want to make sure that we've got great documentation, that we've got processes, that the enterprise architects are involved in helping us document our standards, and we've got buy-in from the business to understand what our domain models should look more broadly. So, some challenges, hopefully some answers, but really the big superhero of event-driven architecture is domain-driven design. So I like this quote that the reason that software projects fail is never technology, it's always communication. And so helping find tools that build effective communication is really, really important, critical to building any system, particularly in event-driven architectures where the gaps in communication so quickly spiral out of control. And when bad communication has, when we have this decoupling and when producers don't know about consumers, it gives us lots of places where we can go off and make changes, not have to communicate, and that means we have to double down on communication where it's most important. So benefits of domain-driven design, we're increasing our understanding across the organization, and that's not just technology teams. By going and helping building these domain models, we're having to really dive deep with our line of business owners who are telling us what they want from the business and what the requirements are. It helps us build the right collaboration between teams, scalable, effective communication. It helps us build those domains and certainly recommend event storming, as Dave mentioned. If you haven't done it, it's really valuable. If you have done it, I think he's right. The fun bits are the arguments everyone has about which domains services live in and who owns them and how we actually describe things. It also helps us map this organizational structure to those business decisions. So how should we structure our teams? Who should be committing to what repo? How are we deploying those services? What's the right cadence? Where should we be buying services off the shelf? Where should we be investing custom development? And Dave also used this quote about developers misunderstanding, not domain object experts' knowledge gets released into production. I think we'll see with all of these patterns, they start off with customers trying to do the right thing. They're trying to act with the information they have now, and they're also trying to minimize feedback loops. They're trying to ship quickly, and so they're trying to only work with the information they have in this sprint. They don't want to over-design. They don't want to go into 3 months of requirements gathering before they build something. So actually, this misunderstanding is almost baked into the practices that we have built in. So I think that it's really, really important to think about that and think about how we're going to address those early changes. I also think it's really important to think in design patterns. So all of these patterns that I've talked about have been around for a while. Got Gregor, who's one of our enterprise evangelists here at AWS. He wrote a book called Enterprise Integration Patterns. I think it's 20 years old this year. So 10 years before Lambda was invented, which was released 10 years ago this year. And all the patterns he talks about here are exactly the same thing as the patterns we talk about when we're talking about event-driven architectures. So he's talking about open host services and claim checks, and really, when I started my career 20 years ago, these concepts were really, really relevant. What I think is revolutionary about implementing event-driven architectures today in 2024 is how easy it is to do it, because you can go and stand up an event bridge in 2 minutes and start publishing events. When I started my career, if you wanted an event, like an enterprise service bus to do messaging, we had to go to procurement, there'd be a huge negotiation, we'd have to buy tin in the data center to go and execute it, and it could be a multi-year project, and then once we'd made that decision, it was a one-way door and we couldn't change our minds. Nowadays, you can spin up an SNS, an SQS, an event bridge, even a MSK in minutes, depending on the architectural requirements of your application, which means you can actually implement these patterns really, really quickly. I linked to a great talk that Gregor does about how those original enterprise integration patterns map to serverless, as well as things like a concept he's been talking about as architecture as code and how we express all these things in CDK. So always super fascinating from Gregor. So I think That's all I've got time for now, so I've rattled through, but I've got a little bit of a survey here. I'd love a bit of feedback if you'd like to share a few more details. Thanks a lot. Thanks for joining me.